Welcome to another video series. In this particular series, we are going to look at the roadmap for software architects. Hi, I'm Vivin Arana and I'm going to walk you through this particular video series. In this particular series, we will cover 8 different things, which include first, we'll start with documentation. The next section will be about design principles. Next, we're going to talk about configuration management. We're going to talk about monitoring and logging. Next, we're going to go into infrastructure as code. We're going to look at different modeling tools and we'll look at architecture patterns after that. And finally, we will look at CI/CD, which is continuous integration and continuous deployment. So in the first particular series or first particular video, this video, we're going to talk about different documentation type. And the different documentation types that a developer or an architect needs to know are Markdown, Sphinx, Asciidoc, Doxygen, and Javadoc. Now these are separate and different. So I'm going to go over each one of them specifically. So let's start with Markdown. Markdown is a lightweight markup language with plain text formatting syntax. It's often used to format README files for writing messages in online discussion forums and to create rich text using a plain text editor. Now some of the key features include, as I mentioned in our overview, simplicity, easy to write and read. Next is formatting, which supports headers, lists, bold, italics, links, images, and code blocks. It also is very compatible, so compatibility can be converted to HTML and other formats using various tools. So these are some of the key features. Now usage, where is it used? Creating documentation files like readme.md for GitHub projects, that's where it's used for writing blog posts, and used for preparing notes and documentation for various purposes. Now let's look at an example. In this particular example, I've created a heading by giving the # markdown example. You can create a subheading by using $. You can create bullet points by using the dash. And as I mentioned, you can do bold and italics by using the star twice for bold and once for italic text. You can also use the backtick or backquote 3 times and add code block inside that so it looks nicer whenever it's rendered anywhere. The next documentation tool that we're going to look at or an architect should know is Sphinx. Now Sphinx is a tool that makes it easy to create intelligent and beautiful documentation. Initially created for only Python documentation, it has excellent support for a wide range of programming languages. Some of the key features include the restructured text or REST uses restructured text as its markup language in Sphinx. Next key feature is extensibility, where highly extensible with a large number of plugins available. Next is themes, various built-in themes for the HTML output. And last one is inter-document linking, where supports cross-reference documentations and sections where you can do much branching and sub-classifications and stuff. So these are some of the key features of Sphinx. Usage is documenting Python projects and creating websites and project documentation with complex structure and multiple documents. Here is an example of Sphinx. Sphinx example. You can create a paragraph with stars like a bold text and italic text similar to markup. You can create a code block with with colon signs and provide the language over there, and also create examples. Here's a Python example of a Python function which is called example. So this is a Sphinx example. Next we look at Asciidoc. Now Asciidoc is a text document format for writing notes, documentations, articles, books, and more. It can be translated to many formats including HTML, PDF, and man pages. Some of the key features include it's very versatile, which is suitable for complex documentation like books and manuals. It's semantic markup, which provides rich semantic markup capabilities. It's customizable, which is highly customizable output formats, as I mentioned earlier. Some of the usage is writing documentation for software projects, creating books and technical manuals, preparing articles and papers. Here is an example of Asciidoc. If you see, the headers are given by equal to sign, subheadings by double equal to. You can create bullet points using the star. You can bold by adding text in between star signs, And for italic text, you can use underscore. You can specify a code block by saying source and what language it is in square brackets, and provide the code in between the 4 dashes that we have created here. Next, Doxygen. Now, Doxygen is a documentation generator primarily for C++, C, and other programming languages. It extracts comments from source code and generates comprehensive documentation. So you do not have to do much. So some of the key features include the code comments. It generates documentation from specifically formatted comments in the source code. So you have to make sure that your source code has the right documentation already provided by the dev. Output formats supports HTML, LaTeX, RTF, and more. And as per diagrams, can generate diagrams for class hierarchies and dependencies. So it automatically does it for you. Now, usage is documenting source code in C++, C, Java, Python, and other languages. It's creating reference manuals from code and annotations. So that's what it can be used for. Here is an example. It looks much like, if you look at this, this is a source code actually, where you can say that a Doxygen example by @brief sign and detailed description of the function, you can provide it there. And here is an example of function implementation which is there, but above inside the comments we have probably used the Doxygen example using the @brief, where you provide all the description for that particular function. Next one, Javadoc. Javadoc is documentation generator for Java. It reads Java source code and produces HTML documentation files from specially formatted comments. Now, key features are standardized format, so standard tool for Java documentation. HTML output generates comprehensive HTML documentation for your code, and API documentation used for generating API documentation from Java source code. So if you're providing API contracts to someone, this is much more helpful. The usage is documenting Java classes, interfaces, methods, and fields. It creates API documentation for Java libraries and applications, which can be shared. So you don't have to share the actual code, but if your code is well documented, this can extract that and provide documentation for other teams to look at. Now here is an example. Now inside a particular example class here, which is written in Java, we have Javadoc, where detailed description is provided. You can create the example method, and over there you can specify like what parameter is required for this particular function. You can add that inside the comments, and Javadoc will extract all these comments and create a documentation for you. So the key features for the last two ones, which is Javadoc and Doxygen, is to make sure that when you are doing your PR reviews, you make sure that the code is well documented, or create a ticket for making sure that documentation is done on the code that is being created. So that's it for documentation, and next we will jump into more details for the next section, which is design principles. So if you have any questions, leave them in the comments, and move on to the next video. Design principles are fundamental guidelines that inform and shape the structure and behavior of software systems. These principles help developers and architects create software that is maintainable, scalable, and adaptable to change. By adhering to design principles, software can be more understandable, flexible, and robust, reducing the risk of errors and making it easier to extend or modify. Some of the key design principles that we are going to talk about in this particular video include solid principles, which emphasize creating software that is well organized and easy to maintain. Next, we're going to look at KISS, which is keep it simple, stupid, which encourages simplicity in design to avoid unnecessary complexity. Next, we're going to look at GRASP, which is general responsibility assignment software patterns, which provides patterns for assigning responsibilities in object-oriented design. Next, we look at YAGNI, which is you aren't gonna need it, which advises against implementing features until they are actually needed. Finally, we're going to look at DRY, which is don't repeat yourself, which focuses on reducing duplication in code to ensure consistency and maintainability. Together, these principles serve as a foundation for building high-quality software that meets both current and future requirements. Solid is a set of 5 design principles intended to make software designs more understandable, flexible, and maintainable. S stands for single responsibility principle. A class should have only one reason to change, meaning it should have only one job or responsibility. O stands for open closed principle, OCP. Software entities, classes, modules, functions, etc. should be open for extension but closed for modification. L stands for Liskov substitution principle, or LSP. Objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. I stands for Interface Segregation Principle, or ISP. No client should be forced to depend on methods it does not use. This means creating specific interfaces instead of single general purpose interface. D stands for Dependency Inversion Principle, or DIP. High-level modules should not depend on low-level modules. Both should depend on abstractions, example, interfaces. Abstractions should not depend on details. Details should depend on abstractions. Here is an example in Java code where we have a class a class called as user with private string name. The user related properties and methods can be defined here. Then we have a user service which has a public void save user method inside it. Logic to save the user to database will be returned here. One of the examples of OCP is here where I have a shape interface where I have created a function double area. Then a class circle here which implements the shape which is the above interface and kind of defines the double area method in here. We also have the square class which implements shape again and has the double area function implemented here. Same for next we have the class area calculator which has the double calculate area function inside here which takes the shape function and returns shape.area depending on which shape it is. KISS, keep it simple stupid. The KISS principle states that simplicity should be a key goal in design and unnecessary complexity should be avoided. When some of the key points include the simplicity, which says keep designs and code as simple as possible. Next key point is avoid over engineering. Do not add functionality unless it is absolutely necessary. Next one is ease of understanding. The simpler the code, the easier it is to read, understand and maintain. So here is an example for KISS which is written in Python where I have a calculate area function which takes shape and dimensions as parameters, where I check if shape equal to circle, return this, if shape equal to square, return this or return none. Now simple and clear code here where I am writing kind of using whatever we wrote above into two different functions, calculate circle area which is called and calculate square area which is called by calling that function. So instead of making it more complex, we can create simple functions and call them directly. GRASP, General Responsibility Assignment Software Pattern. Now GRASP is a set of principles for assigning responsibilities to classes and objects in object-oriented design. The patterns it has is, first one is information expert, assign responsibility to the class that has the necessary information to fulfill it. The creator pattern, where assign responsibilities to create an instance of a class to the class that aggregates, contains or closely uses the created object. Next pattern is controller, is assign the responsibility of handling system events to a controller class. Low coupling pattern aims to reduce the dependencies between classes to make the system more modular and easier to maintain. We have the high cohesion pattern which keep the related behaviors and data together in a class to make the system more understandable and maintainable. We also have polymorphism pattern where assign responsibilities based on dynamic or runtime types. We have pure fabrication pattern which talks about assigning responsibilities to classes that do not represent a concept in the problem domain but are created to achieve a design goal such as improving cohesion or reducing coupling. Indirection pattern, assign responsibilities to an intermediary object to decouple interaction between components. We have finally protected variations pattern, which says protect elements from variations in other elements by wrapping the unstable elements with stable interfaces. Here is an example. Look at the information expert example here, where we have a class order which takes an element private list items with a function of calculate total, which returns back double, where initially is set to 0, and then for each item we iterate through that and increment the price for that particular item and return the total. There is also an creator example where we have a customer class which has a function create order which returns back order, where it will return back the order. YAGNI, you aren't gonna need it. YAGNI is a principle of extreme programming that states you should not add functionality until it is necessary. Now, key points are avoid premature optimization, do not implement features until they are required. Next is focus on current requirements, implement only the functionalities needed for the current situation. Here is an example where you're adding unnecessary features, like we have the calculate area where it takes shape, dimensions, color, filled equal to true. Now if shape equal to circle, it will return back the area for that. Shape equal to square, it will return the area. Now why do we need color and filled properties for this? We don't need those. So we are adding unnecessary features inside this particular function. Now keeping it simple, in the next here, we just return back, we take the radius for the circle and then return back the area. We take the side for the square and return back the area. So we keep it simple. Dry or don't repeat yourself. The dry principle emphasizes the reduction of duplication in software design, meaning that every piece of knowledge must have a single, unambiguous, authoritative representation within the system. Key points include avoid duplication, prevent code duplication to ensure maintainability. We have single source of truth, where you ensure that any piece of information or logic exists in only one place in the code base. Easier maintenance, which says changes need to be made in only one place. Now here is an example for dry where we have some duplicate code where I'm calculating the radius, calculating the cylinder volume, which takes the radius and height. Now with dry code, what you do is you calculate the area, pass the radius, but when you are doing the cylinder volume, you pass the radius and height, but then you call the circle call the calculate area inside here and pass the height, because you're doing the same thing twice in the duplicate code, whereas you can call the existing function. So next time when you change something, if you have to change something, you can change it at one place and not multiple places. Now each of these principles guides software development towards more maintainable, flexible and understandable code. By adhering to these principles, you can create systems that are easier to modify, extend and understand. If you have any questions on this particular section, let me know in the comments and I'll get back to you. Configuration management is a crucial aspect of IT infrastructure management that ensures systems are properly configured and maintained in a consistent state. It involves the automation of system setup, configuration and management processes, reducing the manual effort required to manage large-scale infrastructures. By automating these processes, configuration management tools help to reduce errors, increase efficiency, and ensure that environments are consistently configured across various systems. The key configuration management tools that we are going to cover right now are Ansible, Puppet, Chef, SaltStack, and CFEngine. Let's go over Ansible first. Ansible is an open source automation tool used for configuration management, application development, and task automation. It uses a simple human readable language YAML to describe automation jobs, making it easy for users to write and understand automation scripts. Now, the key features of Ansible are its agent test. Ansible operates without the need for agents on the client systems communicating over SSH. Simple syntax, uses YAML for playbooks which are easy to write and understand. Idempotency ensures that changes are only applied when necessary, avoiding unnecessary actions. Extensibility supports custom modules and plugins. Some of the use cases involve automating server configurations, orchestrating multi-tier deployments, and managing cloud infrastructure. Here is an example of a YAML configurable file for Ansible, where you provide the name, in this case install and configure nginx. The hosts are web servers. You specify the task that needs to be done for the deployment process, where it's saying the name of the particular task, the app which is name and state, again name of this next one, the service that needs to run. So that's how this particular Ansible is configured using YAML file here. Puppet. Puppet is widely used configuration management tool that automates the management of infrastructure through code. It uses a declarative language to describe the desired state of systems and automatically ensure that they are in that state. Now, the key features include the declarative language. Puppet's domain-specific language, which is DSL, allows users to declare the desired state of resources. The next feature is resource abstraction. It abstracts system configuration into manageable resources, making it easier to define configurations. Node classification allows classification of nodes to apply different configurations based on node roles. Reporting provides detailed reporting and logging for tracking changes and compliance. Use cases involve managing large-scale infrastructure with diverse operating systems, ensuring compliance and consistency across environments, and automating application deployment. Here is an example of a Puppet file where I've created a class nginx which has package nginx and ensure that it's in store. Next, I'm talking about the service nginx, ensure it's running and enable it to true. The file where the configuration is etc nginx configuration, ensure that file is there, and the content of this is coming from a template file which is an ERB file mentioned in the path. Chef. Chef is powerful configuration management tool that uses Ruby based DSL for writing configuration recipes. Chef automates the configuration, deployment, and management of infrastructure, enabling organizations to manage servers in a scalable way. The key features include infrastructure as code, uses code to define the desired state of systems. Next one is cookbooks and recipes, organized in cookbooks recipes that define how a particular piece of infrastructure should be configured, which makes your life much easier. Extensible. Chef can be extended through custom resources, libraries, and plugins, and also community support, a large community with shared cookbooks and recipes. Use cases involve automating server provisioning and configuration, managing complex heterogeneous environments, and continuous integration and continuous delivery pipelines. Here is an example of a chef file, which is the Ruby file, where we specified what package, what to do, action is installed in this particular case, then this for the service of nginx, enable it, start it, and then finally the template for the configuration of where it exists, and if something happens, notifies the restart with service nginx and end of the file. So this is a particular chef format for configuration of your nginx server. SaltStack. SaltStack, also known as Salt, is an open source configuration management and orchestration tool. It is known for its speed and scalability, using a high speed communication bus to manage thousands of nodes in real time. Some of the key features include event driven architecture, so it supports real time automation and orchestration based on system events. Another feature is flexible architecture, master minion setup with support for both push and pull configurations. It is scalable, so scalability is one of the features where it's designed to manage large scale infrastructure with high performance. And extensibility supports custom modules, states, and grains. The use case for this particular tool is managing large scale dynamic environments, real time infrastructure automation, and event driven configuration and orchestration. Here is a YAML example of a salt file, of a salt configuration. nginx, where you say package install, give the service running, enable to FCC, is much similar to other ones. And the managed file, you provide the name, source, and require package nginx for this particular case. This is an example of a chef or a salt file for this particular configuration in YAML. CFEngine. Now, CFEngine is one of the oldest configuration management tools, known for its lightweight agent and efficiency in managing large-scale infrastructure. It uses a declarative language to define the desired state of the system. Key features involve its lightweight with minimal resource usage, making it suitable for managing large number of systems. Its scalability, designed to manage tens of thousands of nodes efficiently. Has security, uses cryptographic keys for secure communications, and autonomous agents, where agents that can run independently and periodically enforcing the desired state. Use cases involve managing large distributed environments with minimal overhead, ensuring compliance and security across a large number of nodes, and automating configuration management in resource constrained environments. Example file for a CFEngine looks something like this, where you provide a bundle with agent and example. In this particular case, where we have package nginx, policy is present, services that you need nginx, I want policy to be running and require package nginx, and files, I'll provide a configuration file etc nginx ng configuration and copy from a particular path and provide a salt for that particular case and require package nginx in this particular case. So this is how CFEngine works. So to summarize what we have done in this particular video, each of these configuration management tool has its own strengths and is suited to different use cases. Ansible is great for simple agentless setups, while Puppet and Chef are well suited for managing large and complex environments with extensive community support. SaltStack excels in real-time event-driven automation, and CFEngine is ideal for managing large number of nodes with minimal resource usage. By understanding and leveraging these tools, different organizations or you can achieve greater consistency, reliability, and efficiency in managing your IT infrastructure, ensuring that systems are configured correctly and remain in the desired state across diverse environments. If you have any questions in whatever we covered in this particular section on configuration management, let me know in the comments and I'll get back to you. Monitoring and logging are essential components of modern IT infrastructure management. Monitoring involves continuously observing systems, applications, and services to ensure they are running optimally and to detect and respond to issues promptly. Logging, on the other hand, involves collecting, storing, and analyzing log data generated by systems and applications. Together, monitoring and logging provide the visibility needed to maintain the health, performance, and security of IT environments. In this particular video, we're going to look at some key monitoring and logging tools which include Relic, Grafana, Prometheus, ELK stack, and Splunk. Let's jump into Relic. Relic is a powerful cloud-based application performance monitoring or APM tool that provides real-time insights into the performance of web and mobile applications. It helps developers and operations team monitor the health of applications, detect performance bottlenecks, and troubleshoot issues quickly. Some of the key features include APM, which is the application performance monitoring. It provides detailed performance metrics for applications including response times, throughput, and error rates. Another feature is infrastructure monitoring. Monitors server health, network performance, and cloud services. Distributed tracing traces requests as they flow through various services, helping to pinpoint performance issues. Real-time dashboards offers customizable dashboards to visualize metrics and key performance indicators (KPIs). Alerting generates alert based on predefined thresholds or anomaly detection. Some of the use cases of New Relic include monitoring the performance of web and mobile applications, diagnosing and resolving performance issues, tracking application health in real time. One of the examples you can think of is like New Relic allows you to monitor the response time of your web application, track database query performance, and set up alerts for when the response time exceeds acceptable thresholds. Grafana. Grafana is an open source analytics and monitoring platform that enables users to create and share dynamic dashboards for visualizing metrics for a wide variety of data sources. It is widely used in conjunction with other monitoring tools like Prometheus, InfluxDB, and Elasticsearch. Some of the features include customizable dashboards. It creates interactive and visually appealing dashboards. Data source integration supports a wide range of data sources including Prometheus, InfluxDB, Elasticsearch, MySQL, and more. Alerting set up alerts and notification based on data trends and thresholds. Templating it uses variables and templates to create reusable and dynamic dashboards. Plugins extend functionality with a variety of plugins for different data sources, visualizations, and tools. Use cases include visualizing time series data from various sources, building monitoring dashboards for infrastructure and applications, and setting up alerts to proactively manage system performance. Example might be Grafana can be used to create a dashboard that visualizes CPU and memory usage across multiple servers, which with alerts configured to notify the team when usage exceeds predefined limits. Prometheus. Prometheus is an open source monitoring and alerting toolkit particularly suited for cloud native and microservices environment. It collects and stores metrics as time series data, providing powerful query capabilities via PromQL, which is Prometheus query language. Some of the key features include time series data. It stores metrics with a timestamp, allowing for detailed historical analysis. PromQL, a flexible query language for querying and aggregating time series data. Service discovery automatically discovers targets from various systems and environment. Alerting integrated alerting with customizable rules and notifications, and it also has pull-based model, collects metrics using a pull-based model which allows for better scalability and reliability. Use cases for Prometheus include monitoring the performance of microservices and containerized environments. It also another use case collecting and querying detailed metrics for system health and performance analysis, also setting up alerts for critical system metrics. Example for this particular tool might be Prometheus can monitor the health of Kubernetes clusters by collecting metrics from the nodes, pods, and services and setting up alerts for issues like high CPU usage or failed deployments. Elk Stack or Elasticsearch, Logstash, Kibana Stack. The Elk Stack is popular open source suite for searching, analyzing, and visualizing log data in real time. It consists of three main components: Elasticsearch, which is search and analytics engine; Logstash, which is the data processing pipeline; and Kibana, which is the visualization tool. Now, key features include log aggregation. It collects and centralized log data from various sources. Search and analyze using Elasticsearch to index and search through logs quickly and efficiently. Another feature is data transformation. Logstash can transform and enrich log data before it is indexed in Elasticsearch. Visualization. Kibana provides powerful tools for creating visualizations and dashboards based on log data. Scalability. Elk Stack can scale to handle large volumes of log data across distributed systems. Some of the use cases for Elk Stack are centralizing logs for multiple systems and applications, searching and analyzing log data to troubleshoot issues, and creating dashboards and visualizations for log data to monitor system health. Example for this I can think of is the Elk Stack can be used to centralize log from a web server, application server, and a database server, allowing you to search for specific errors and visualize traffic patterns in Kibana. Finally, Splunk. Splunk is a comprehensive platform for searching, monitoring, and analyzing machine-generated big data. It is widely used for log management, security information, and event management (SIEM) and operational intelligence. Now, the key features include log management, which collects, indexes, and analyzes log data from virtually any source. Search and analysis, powerful search capabilities to query log data in real time. Data visualization provides interactive dashboards, graphs, and charts for visualizing data. Alerting, real-time alerts based on predefined conditions or anomaly detection. Machine learning, built-in machine learning tools for predicting analytics and anomaly detection. Use cases include managing and analyzing logs from various IT systems and applications, security monitoring and incident detection using SIEM, and gaining operational insights through real-time data analytics. Example for Splunk can be used to monitor security logs across an enterprise, detecting and alerting on suspicious activities like unauthorized access attempts or unusual network traffic patterns. To summarize, whatever we have done in this particular video is more on monitoring and logging are indispensable for maintaining the performance, reliability, and security of IT environments. Tools like Relic provide in-depth application performance monitoring, while Grafana offers powerful visualization capabilities for various metrics. Prometheus excels in collecting and querying time series data, particularly in cloud-native environments. The Elk stack is a versatile solution for log aggregation and analysis, and Splunk provides a robust platform for log management and operational intelligence. Together, these tools help organizations gain comprehensive visibility into their systems, allowing them to proactively manage and optimize their IT infrastructure. If you have any questions on this particular section, let me know in the comments. Infrastructure as code. Infrastructure as code, also short for IAC, is a key DevOps practice that involves managing and provisioning computing infrastructure through machine readable scripts or code rather than through manual processes. This approach allows for consistent, repeatable, and automated infrastructure management, which helps reduce human errors, speed up deployments, and improve the scalability and reliability of IT environments. Some of the key tools that we're going to look here are Terraform, CloudFormation, Pulumi, Ansible, and SaltStack. Now let's go through the first one, which is Terraform. Terraform is an open source IAC tool developed by HashiCorp. It allows users to define and provision infrastructure using a high-level configuration language known as HashiCorp Configuration Language or HCL. Terraform is cloud agnostic, meaning it can manage infrastructure across various providers like AWS, Azure, Google Cloud, and others. Some of the key features of Terraform include cloud agnostics, where it supports multiple cloud providers and on-premises environments. Its declarative configuration, which infrastructure is defined in a declarative manner where the desired state is specified. State management maintains the state of the infrastructure, allowing for incremental changes and ensuring consistency. It's modular, supports reusable modules, enabling efficient management of large complex environments. Community support, a large and active community with numerous pre-built modules are available. Some of the use cases include automating the provisioning of cloud resources, managing multi-cloud or hybrid cloud environments, and implementing and managing complex infrastructure setups. Here is an example for Terraform where I'm saying provider is AWS and the region at where this cloud is installed is at US West 2. Resources needed is AWS instance, which is called as example, and AMI that is using is AMI 1234567 Instant type is t2.micro. So this is how you can create a Terraform instance using the HCL language. CloudFormation. Now, AWS CloudFormation is an IAC service provided by Amazon Web Services that allows users to define and provision AWS infrastructure using templates written in JSON or YAML. CloudFormation automates the deployment and management of AWS resources, ensuring that infrastructure is consistent and predictable. Some of the key features include its AWS native is designed specifically for managing AWS resources. It's template driven. Infrastructure is defined using templates making it easy to replicate environments. Stack management manages resources as a stack, allowing for easy creation, updating, and deletion of infrastructure. Drift detection identifies changes in the stack's configuration and alerts users to inconsistencies. Integration integrates seamlessly with other AWS services like IAM, CloudTrail, and more. Some of the use cases for this cloud formation include managing AWS infrastructure for production environments, automating complex deployments on AWS, and ensuring consistency and compliance across AWS environments. Here is an example of cloud formation where I have a YAML file where you specify resources, which is in this case my instance, type AWS EC2 instance, properties are instance type is T2 micro, and image ID is AMI 1234567. Pulumi. Pulumi is an open source IAC tool that allows infrastructure to be defined using general purpose programming languages like Python, JavaScript, TypeScript, and Geo. This approach enables developers to leverage existing programming knowledge and tools to manage infrastructure. Some of the key features of Pulumi are it's code-based, where infrastructure is defined using familiar programming languages rather than domain-specific languages. It's multi-cloud support, supports multiple cloud providers including AWS, Azure, Google Cloud, and Kubernetes. Reusable components allows the creation of reusable infrastructure components similar to software libraries. State management manages infrastructure state, allowing for predictable updates and rollbacks. Strong typing and testing offers strong typing IDE support and unit testing capabilities for infrastructure code. Some of the use cases include managing complex infrastructure using existing development skills, creating reusable and shareable infrastructure components, and integrating infrastructure management with application code. Here is an example of Pulumi using Python, where I'm importing Pulumi first and then I'm importing Pulumi AWS as AWS, which is an AWS module for Pulumi. Then I'm saying instance equal to AWS.ec2.instance. My instance type is T2 micro and AMI is AMI123. Ansible. Ansible is an open source automation tool that simplifies configuration management, application deployment, and task automation. We already looked at this at configuration management. Now, while it is primarily known for configuration management, Ansible also supports IAC through its playbooks, enabling users to define infrastructure in a declarative manner. Now, some of the key features include it's agentless, operates without agents or managed nodes using SSH for communication. A simple syntax uses YAML for playbooks, making it easy to write and understand. Idempotency ensures that the desired state is applied without redundant actions. Ansible Galaxy, a repository of pre-built roles and playbooks for common tasks. Extensibility supports custom modules and plugins. Some of the use cases include provisioning and managing infrastructure across different environments, automating configuration management and software deployments, and orchestrating complex multi-tier applications. Here is an example in YAML where I am providing the name, provisioning, and configuring web server. Hosts are web servers, have tasks where the first task is install nginx and the second one is start the nginx server. SaltStack. SaltStack is an open source automation and configuration management tool that also supports IAC. It is known for its speed and scalability, using a high-speed communication bus to manage large-scale infrastructures in real time. And we already saw this in configuration management. Some of the key features include its event-driven architecture, supports real-time event-driven automation and orchestration. Flexible architecture, master minion setup with support for both push and pull configurations. Scalability, designed to manage large-scale infrastructure with high performance. YAML-based, uses YAML for configuration similar to Ansible. Custom modules, supports custom modules and states for complex tasks. Use cases include managing large-scale dynamic environments with real-time automation, automating infrastructure provisioning and configuration, and handling complex orchestration tasks in distributed environment. Here is an example of using SaltStack where I've created a YAML file and I'm saying that nginx is what I need, package installed, service running, enabled it to true, requiring package nginx. Very simple and straightforward. Now to summarize, infrastructure as code is a transformative approach to managing IT infrastructure, enabling automation, consistency, and repeatability in deployment processes. Tools like Terraform and Pulumi offer cloud-agnostic solutions, allowing infrastructure to be managed across multiple providers using either declarative or code-based approaches. CloudFormation is ideal for AWS-centric environments, providing deep integration with AWS services. Ansible and SaltStack bring additional functional flexibility, combining configuration management with ISC capabilities. Together, these tools empower organizations to efficiently manage and scale their infrastructure, reduce manual errors, and accelerate deployment cycles, all while maintaining a high level of control and visibility over their environments. If you have any questions on infrastructure as code, leave them in the comments and I'll get back to you as soon as possible. Modeling tools are essential for software architects, system designers, and business analysts. They provide a visual representation of systems, processes, and architectures, allowing teams to understand complex structures, communicate ideas effectively, and plan changes systematically. These tools are crucial in both the design phase of software development and in the ongoing maintenance and evolution of systems. In this particular video, the key modeling tools that we will be looking at include Archi-Mate, Microsoft Vision, Lucidchart, Sparx Systems Enterprise Architect, and Draw.io. Let's jump into Archi-Mate. Archi-Mate is an open and independent enterprise architecture modeling language that provides instruments to describe, analyze, and visualize the relationships among business domains in an unambiguous way. It is widely used for enterprise architecture modeling, allowing architects to describe the structure and behavior of business processes, organizational structures, information flows, IT systems, and technical infrastructure. Some of the key features of Archi-Mate include enterprise focused. It's specifically designed for modeling enterprise architectures, including businesses, application, and technology layers. Standardized language. It provides a standardized notation which is part of the Open Group's TOGAF framework. Interoperability. Compatible with various enterprise architecture tools, supporting a wide range of modeling needs. And finally, layered view. Supports multiple layers of abstraction from high-level business processes to detailed technical architectures. Some of the use cases for Archi-Mate includes designing and analyzing enterprise architectures, visualizing complex IT systems and their interactions with business processes, and supporting strategic planning and decision making in organizations. Let's look at an example. Archi-Mate can be used to model the interaction between a company's business processes and its underlying IT infrastructure, illustrating how changes in one domain impact the others. Microsoft Visio. Microsoft Visio is a diagramming and vector graphics application that is widely used for creating flowcharts, network diagrams, organizational charts, and other visual representations of processes and systems. Visio is known for its ease of use and integration with other Microsoft Office products, making it a popular choice for business and technical professionals. Some of the key features include wide range of templates. It offers a vast array of pre-built templates and shapes for different types of diagrams. Integration. It seamlessly integrates with Microsoft Office Suite, allowing for easy data import and export. Customization. Users can customize shapes, templates, and themes to match specific requirements. Collaborative features. Supports co-authoring and real-time collaboration, enabling teams to work together on diagrams. Let's look at some of the use cases. One of them is creating business process diagrams, flowcharts, and organizational chart. Next, you can design network diagrams and IT infrastructure layouts. And you can document system architectures and software designs. Now, example of Microsoft Visio can be used to create a detailed network diagram that maps out an organization's IT infrastructure, including servers, routers, and connections, and also how the data flows through all these. Lucidchart. Lucidchart is a web-based diagramming tool that offers a simple and intuitive interface for creating a wide range of diagrams. It supports flowcharts, organizational charts, wireframes, UML diagrams, and more. Lucidchart is particularly well regarded for its ease of use, collaboration features, and integration with cloud services. Some of the key features include it's cloud-based, it's fully online with no need for software installation and accessible from any device. Real-time collaboration supports real-time editing and collaboration, making it ideal for remote teams. Templates and shapes offers a variety of templates and shapes for different diagramming needs. Integrations. It integrates with popular platforms like Google Workspace, Microsoft Office, Slack, and Atlassian tools. Some of the use cases include is collaboratively creating flow charts and process diagrams, visualizing software architectures and data flows, and designing organizational structures and project timelines. Example of Lucidchart can be used by a distributed development team to collaboratively design a software systems architecture, including the flow of data between microservices. Sparx System Enterprise Architecture. Sparx Systems Enterprise Architect is a comprehensive modeling tool that supports a wide range of standards and methodologies, including UML, BPMN, SysML, and Archi-Mate. It is designed for enterprise-wide modeling, allowing for detailed and complex models of systems, software, and business processes. Some of the key features include extensive modeling capabilities. It supports UML, BPMN, SysML, Archi-Mate, and more, catering to a broad spectrum of modeling needs. Collaboration. It offers collaborative features for team-based modeling, including version control and role-based access. Simulation and analysis. It provides simulation capabilities for business processes and software models. Traceability. It ensures traceability between different model elements, aiding in impact analysis and project management. Use cases. Some of the use cases include modeling complex software systems and enterprise architectures, creating detailed business process models and workflows, and analyzing system behavior and conducting impact assessments. Examples of Sparx System Enterprise Architect where it can be used to model a complete enterprise system, showing how business requirements translate into technical specifications and how various system components interact with each other. Draw.io. Draw.io, which is now part of diagrams.net, is a free online diagramming tool that supports a wide variety of diagram types, including flowcharts, network diagrams, UML diagrams, and more. It's known for its simplicity, ease of use, and integration with popular cloud storage services like Google Drive and Dropbox. This is also one of my favorite ones which I use on a daily. Key features of Draw.io include free and open source, completely free to use with no premium plans, and the source code is available for customization. Browser based, accessible through any web browser with no need for installation. Extensive templates, offers numerous templates and shapes to get started quickly. Integration with cloud storage, supports saving diagrams directly to Google Drive, Dropbox, OneDrive, and other cloud services that your organizations or you might be using. Some of the use cases include creating quick, simple diagrams for various purposes, designing flowcharts, network diagrams, and UML diagrams, sharing diagrams with team members via cloud storage. Example, Draw.io can be used to create a simple flowchart illustrating a user's journey through a software application, highlighting decision points and possible outcomes. So here what we learned is modeling tools like Archi-Mate, Microsoft Visio, Lucidchart, Sparx System Enterprise Architect, and Draw.io play a crucial role in the design, communication, and documentation of complex systems and processes. Archi-Mate is ideal for enterprise architecture, offering a standardized approach to modeling businesses and IT landscapes. On the other hand, Microsoft Visio provides a user-friendly environment for creating a wide range of business and technical diagrams. Lucidchart excels in collaboration, enabling teams to work together in real time on various types of diagrams. Whereas Sparx System Enterprise Architect is suited for detailed enterprise-wide modeling, supporting multiple standards and methodologies. Draw.io offers a free, simple solution for creating diagrams quickly and sharing them via cloud services. Together, these tools empower professionals to visualize, design, and manage complex systems effectively. If you have any questions, leave them in the comments and I'll get back to you. Architecture patterns are reusable solutions to common problems in software architecture design. These patterns provide a framework for structuring systems, making them easier to understand, develop, and maintain. By using architecture patterns, architects can ensure that systems are scalable, flexible, and robust, while also meeting the specific needs of their projects. In this particular section, we will explore 5 key architecture patterns, which are layered architecture, monolithic architecture, microservice architecture, event-driven architecture, and serverless architecture. Let's start with layered architecture. Layered architecture, also known as N-tier architecture, is one of the most common patterns used in enterprise applications. It organizes the system into layers, each with a specific responsibility, and typically includes layers such as presentation, business logic, data access, and database. Some of the key features include: first, separation of concerns. Each layer is responsible for specific aspect of the application, promoting modularity and maintainability. Reusability. Components within a layer can often be reused across different applications. Ease of development. The clear separation of responsibilities simplifies development and testing. Use cases include enterprise applications where different teams manage different layers, systems that require clear separation between the user interface, business logic, and data storage. Let's look at an example. An e-commerce application might have presentation layer for the user interface, a business logic layer for processing orders, a data access layer for interacting with databases, and a database layer for storing that product information. Of layered architecture include easy to manage and maintain, promotes reusability and separation of concerns, and simplifies testing by isolating layers. On the other hand, cons include can become rigid and difficult to modify as the application grows, performance overhead due to multiple layers. Monolithic architecture. Monolithic architecture refers to a single unified software application where all components are tightly coupled. In a monolithic system, the user interface, business logic, and data access layers are all part of one code base and are deployed as a single unit. Key features include single code base. All application functionality is contained within one code base. Unified deployment. The application is deployed as a single unit, making it simple to deploy and manage. It's tightly coupled. Components within the application are tightly integrated and interdependent. Use cases include small to medium-sized applications with simple requirements, applications where performance is critical and there is a need for tight integration between components. An example would be a simple web application with a user interface, business logic, and database interactions, all contained within a single code base and deployed as one executable file. Pros of this include simplified development, testing, and deployment process, high performance due to tight integration, and easier to debug and trace issues within a single code base. Cons include difficult to scale and modify as the application grows. This tightly coupled component makes it harder to introduce changes or updates. A single point of failure can affect the entire system. Microservices architecture. Microservices architecture is a style of architecture where an application is composed of small, independent services that communicate over a network. Each microservice is responsible for a specific functionality and can be developed, deployed, and scaled independently. Key feature includes decentralization. Each service is autonomous and can be managed by different teams. Scalability. Services can be scaled independently based on demand. Technology agnostics. Different microservices can use different technologies and programming languages. Use cases include large and complex applications where different components need to be developed and scaled independently. Applications requiring frequent updates and deployments. Example can be an online retail platform with separate microservices for user management, product catalog, shopping cart, and payment process, each of which can be developed and scaled independently. Pros include flexibility to use different technologies for different services, enhanced scalability and resilience, easier to deploy and update individual services without affecting the entire system. Cons include increased complexity in managing multiple services, challenges in maintaining consistent data and handling transactions across services, higher operational overhead due to the need for inter-service communication and orchestration. Event-driven architecture. Event-driven architecture is a pattern where the flow of the application is determined by events such as user actions, sensor outputs, or messages from other services. In this architecture, components communicate with each other through events and services react to these events asynchronously. Key features include asynchronous communication. Components communicate through events, allowing for non-blocking interactions. Scalability easily scales by adding more event processors or message brokers. Loose coupling. Services are decoupled as they do not directly communicate but rather react to events. Use cases include applications that require real-time processing of events such as financial trading platforms or IoT systems. Systems where different components need to react independently to changes or updates. Example can be a stock trading platform where buy-sell orders, price updates, and notifications are processed as separate events by different services. Pros for this might be it's highly scalable and resilient, promotes loose coupling between components, making the system more flexible, and it can handle high volumes of transactions and real-time data processing. Cons, on the other hand, complexity in managing and debugging asynchronous flows. Potential challenges in ensuring data consistency across different services and requires robust event management and monitoring mechanisms. Serverless architecture. Serverless architecture is a cloud computing execution model where the cloud provider dynamically manages the allocation of machine resources. In this model, developers focus on writing code without worrying about the underlying infrastructure, as the cloud provider handles all the server management for you. Key features include there's no server management. Developers are not responsible for managing servers, the cloud provider handles it for you. Scalability automatically scales with demand, changing only the actual usage. Event driven functions are triggered by events such as HTTP requests, database changes, or message queues. Use cases include applications with variable or unpredictable workloads such as webhooks or mobile backends. Event-driven applications where different parts of the system need to scale independently. Example would be an image processing application where images are uploaded to a cloud storage service triggering a serverless function that processes the image and stores the results in a database. Pros for this can be it simplifies infrastructure management, allowing developers to focus on the code. Cost effective as users are charged only for actual execution time. It scales automatically based on demand. And on the other hand, cons can be its limited control over the underlying infrastructure, potential cold start latency for infrequent used functions, and complexity in managing state and data persistence across stateless functions. So architecture patterns like layered architecture, monolithic architecture, microservices architecture, event-driven architecture, and also serverless architecture provide frameworks for structuring software systems effectively. Layered architecture offers a modular approach with clear separation of concerns, making it ideal for enterprise applications. Monolithic architecture is straightforward but can become rigid as the application grows. Microservices architecture promotes flexibility and scalability but introduces complexity in managing multiple services. Event driven architecture excels in real time processing and loose coupling, while serverless architecture simplifies infrastructure management, making it perfect for variable workloads and event driven applications. Understanding these patterns helps architects choose the right structure for their system based on the specific needs of their projects. So, if you have any questions on any of these architectures, leave them in the comments and I'll get back to you. Continuous integration and continuous deployment are practices that aim to improve the software development process by automating the building, testing, and deployment of applications. CI/CD helps teams deliver code changes more frequently and reliably, ensuring that software is always in a deployable state. CI involves in the automatic integration of code changes from multiple contributors into a shared repository where they are automatically built and tested. CD extends this by automating the deployment of applications to the production or staging environments. Now, some of the key CI/CD tools that we're going to look in this particular section include Jenkins, GitLab CI/CD, Circle CI, Travis CI, and Bamboo. Now, let's look at Jenkins. Jenkins is one of the most popular open source CI/CD tools, known for its flexibility and extensive plugin ecosystem. Jenkins automates the entire software development lifecycle from building and testing to deploying applications. It supports a wide range of programming languages and integrates with various version control systems, making it a versatile choice for CI/CD pipelines. Some of the key features include extensive plugin ecosystem, over 1500 plugins available for integration with other tools and services. Pipeline as code supports defining CI/CD pipelines as code using the Jenkins file, which can be versioned along with the source code. Distributed builds. It supports building on multiple machines to speed up the CI/CD process. It's customizable, highly customizable to fit specific project needs, including automated testing, deployment, and monitoring. Use cases include automating the build, test, and deployment processes for a wide range of applications, managing complex CI/CD pipelines with multiple stages and dependencies, integrating with various tools such as Git, Docker, and Kubernetes to manage the entire software delivery lifecycle. An example would be Jenkins pipeline can be used to automatically build, test, and deploy a Java application to a cloud environment after each commit to the Git repository. Pros include it's highly customizable and flexible, large community support, and extensive documentation, and it integrates with a wide range of tools and technologies. Cons can be complex to set up and maintain, especially for large scale projects, requires manual configuration for some tasks which can be time consuming. GitLab CI/CD. Now, GitLab CI/CD is a built-in feature of GitLab a popular Git repository management platform if you have used one. GitLab CI/CD allows teams to define, build, test, and deploy pipelines directly within their GitLab projects. It is known for its seamless integration with the GitLab repository, making it easy to manage the entire CI/CD process from a single platform. Key feature is integrated CI/CD. As I said, CI/CD is tightly integrated with GitLab repository, making it easy to trigger pipelines on code changes. Pipeline as code. Pipelines are defined in a git ci.yaml file, which can be versioned along with the project code. Built-in security includes security features like container scanning, dependency scanning, and static application securing test, which is SAST. Scalability supports running pipelines across multiple machines with GitLab runners, which can be hosted on-prem or in the cloud. Use cases for this include managing CI/CD processes directly within GitLab for seamless integration with version control, automating testing and deployment for applications hosted on GitLab, and implementing DevSecOps practices with built-in security testing features. An example can be you can take a .gitlab.ci.yaml file, which can define a pipeline that automatically builds a Docker image, runs tests, and deploys the application to a Kubernetes cluster after each commit. Pros include seamless integration with GitLab for version control and CI/CD, a strong focus on security with built-in testing features, and it's easy to set up and manage, especially for GitLab users. Cons include it's limited to GitLab repositories, making it less flexible for teams using multiple version control systems. Some advanced features may require a paid subscription. Circle CI. Circle CI is a cloud-based CI/CD tool that automates the building, testing, and deployment of applications. It is known for its ease of use, scalability, and support for multiple programming languages. Circle CI offers both cloud-hosted and self-hosted solutions, making it suitable for teams of all sizes. Key features include its ease of use, its simple setup and configuration with pipelines defined in YAML files, customizable workflows. It supports customizable workflows with multiple jobs that can run sequentially or in parallel. Docker integration, strong support for Docker, allowing for easy container-based builds and deployments. Scalability, automatically scales based on the demand, making it ideal for projects with varying workloads. Some of the use cases include automating the CI/CD process for cloud-native applications and microservices, running parallel builds and tests to speed up the development process, and integrating with cloud providers like AWS, Google Cloud, and Azure for seamless deployments. One example can be a Circle CI pipeline can be used to automatically build and test the Node.js application in a Docker container and then deploy it to a cloud environment. Pros include easy to set up and use with a user-friendly interface, strong support for Docker and Docker native applications, and scales automatically to meet the needs of growing teams and projects. Cons can be some advanced features like self-hosted runners require a paid plan and limited customization compared to more flexible tools like Jenkins we discussed. Travis CI. Now, Travis CI is a cloud-based CI/CD tool that integrates with GitHub and Bitbucket repositories. It automates the process of building and testing code, making it easier for teams to deliver software quickly and reliably. Travis CI is popular for its simplicity and integration with open source projects. Some of the key features include GitHub and Bitbucket integration. It seamlessly integrates with GitHub and Bitbucket, making it easy to trigger builds on code changes. Pipeline as code. Pipelines are defined in a .travis.yaml file, which can be versioned along with the source code. Multi-language support. Supports a wide range of programming languages including Java, Python, Ruby, Node.js, you name it. Open source friendly. Free for open source projects with paid plans available for private repositories. Use cases. Use cases include automating the CI/CD process for open source projects hosted on GitHub or Bitbucket, running automated tests for projects in multiple programming languages, and deploying applications to cloud environments directly from GitHub or Bitbucket. Example can be you can create a Travis YAML file which can be define a pipeline that builds and tests a Python application and deploys it to, let's say, Heroku after successful tests. Pros include simple setup and integration with GitHub and Bitbucket, free for open source projects, and supports a wide range of programming languages. Cons can be limited customization and flexibility compared to other CI/CD tools. Paid plans required for private repositories and advanced features. Bamboo. Bamboo is a CI/CD tool developed by Atlassian, the makers of Jira and Bitbucket. Bamboo integrates seamlessly with other Atlassian products, making it a popular choice for teams already using Atlassian's suite of tools. Bamboo supports automated builds, testing, and deployment, and offers a strong support for continuous delivery pipelines. Some of the key features include integration with Atlassian products, so it seamlessly integrates with Jira, Bitbucket, and Confluence, providing a unified development experience. Pipeline as a code supports defining, build, and deployment pipelines as code using Bamboo specs, which can be written in YAML or Java. Deployment projects allows teams to manage and deploy these applications across multiple environments with easy rollback options. Parallel builds. It supports running parallel builds to speed up the CI/CD process. Use cases include managing CI/CD pipelines in environments that heavily use Atlassian tools like Jira and Bitbucket, automating the deployment of applications across multiple environments, and integrating CI/CD processes with project management tools for better tracking and visibility. Example can be a Bamboo pipeline can automatically build, test, and deploy a Java application with integration to Jira for tracking build status and issues. Pros for this Bamboo can be strong integration with Atlassian products, providing a cohesive development and project management environment. Robust support for complex CI/CD pipelines and multi-environment deployments. And flexible configuration options with Bamboo specs. Cons can be it requires a license for use, making it more expensive compared to open source alternatives. And complex setup and configuration, particularly for large scale projects. So CI/CD tools like Jenkins, GitLab CI/CD, Circle CI, Travis CI, and Bamboo play a crucial role in automating the software development lifecycle. Jenkins offers unparalleled flexibility with its vast plugin ecosystem, making it suitable for a wide range of projects. GitLab CI/CD provides seamless integration with GitLab repository, making it a great choice for teams already using GitLab. Circle CI is known for its ease of use and scalability, particularly in cloud-native environments. Travis CI is favored for its simplicity and support for open source projects, while Bamboo excels in environments that heavily rely on Atlassian tools, offering robust integration and deployment capabilities. Together, these tools enable teams to build, test, and deploy their software faster and more reliably, helping to streamline the development process and deliver high quality software more effectively. If you have any questions on any of these, let me know in the comments and I'll get back to you.